Hello everyone, my name is Kluczynska. I'm from Nature Research Center from Vilnius. My speech topic is Cladoceran succession in Čepkeliai bog, southern Lithuania, during the late glacial and Pliocene. Today I will present our study on the Čepkeliai bog in southern Lithuania, where we used Cladoceran analysis to investigate environmental changes during the late glacial and Pliocene. Cladocerans are small freshwater crustaceans whose remains are well preserved in sedimentary deposit. This fossil remains enable the reconstruction of past-like development. They provide valuable insights into environmental conditions such as climate fluctuation, trophic status, pH, and water level changes. The aim of our study was to reconstruct the ecological condition in the reservoir during the late glacial and Pliocene. The analysis revealed information about the composition of Cladoceran species and the associated environmental settings in the region. Our research focused on the Čepkeliai bog, the largest wetland complex in the country. It is located on the marginal zone of the area affected by the late Oexilian glaciation near the Lithuanian-Belarus border. The occurring site is in the southeastern part of the Čepkeliai wetland and is characterized as a typical raised bog. 5 parallel sediment core was taken from the Čepkeliai bog, reaching a maximum depth of 1,600 centimeters. My research focused on the 1,500 to 700 centimeter interval. This study is based on Cladoceran analysis supported by lithological and radiocarbon data. The sediment sequence was divided into 9 lithological units based on visual stratigraphic descriptions. The relative contents of organic matter, calcium carbonate, and mineral material were determined using the loss on ignition method. The chronology was constructed using HC14 dates distributed along the core. According to the results, sedimentation at the Čepkeliai site began shortly before 13,200 years BP. The studied core indicates that the sedimentation process was consistent and continuous throughout the analyzed period. Until now, the Cladoceran analysis method has not been applied in Lithuania. This is the first study to provide information on the supposed Cladoceran species composition in this region. Using standard method, I analyzed 126 sediment samples from a depth range of 707 to 1,485 centimeters. Identified 29 Cladoceran species belonging to four families: Hydorida, Sidida, Busminida, and Daphnida. The Hydorida family was the most diverse, with 24 identified species. The analysis revealed 6 distinct Cladoceran assemblage zones, reflecting key environmental changes over time. This slide presents a visual representation of changes in the Cladoceran community during the Alirot period. In the initial phase, the assemblage was dominated by planktonic species, particularly Busminia longirostis, indicating a deep and open water-like environment. Around 13,000 years BP, a significant ecological shift occurred. This was marked by a decline in planktonic taxa, the disappearance of Busminia longispina, and the emergence of littoral species such as Eurycercus lamellatus, Hydorus sphaericus, and and Alanopsis elongata. This changes suggest that the lake was becoming shallower, promoting the development of aquatic vegetation and new microhabitats. The presence of Alanopsis elongata is suggestive of cooler water conditions, as this species is typically found in cold waters. In the early part of the Younger Dryas, harsh climatic conditions led to a reduction in Cladoceran abundance. Cold-tolerant species such as Acroperus carpera, Eurystheus lamellatus, Alona nana, Sida crystallina, and Hydorus vericus were dominant. Planktonic forms like Bosmina longispina and Bosmina corregoni were scarce, indicating cold oligotrophic condition and likely a relatively shallow basin. Around 12,600 KUSBP, a temporary increase in water level is inferred from the rise of planktonic species such as Eubosmina. This species suggests deeper oligotrophic waters with high transparency. Around 12,000 KUSBP, the water level decreased again, and littoral species became dominant. The cold-adapted Alanopsis elongata disappeared, while warm-adapted taxa such as Camptocercus rectirostis and Alonella axisa increased. These changes indicate improved climate conditions and development of a shallow vegetated basin. This slide focuses on Cladoceran dynamics during the early Holocene. We observe high Cladoceran diversity, including both cold and warm adapted species, indicating a moderately warm and humid climate. Littoral taxa dominate, suggesting shallow lake conditions with extensive macrophyte zones. Mesotrophic conditions are inferred from the presence of both oligotrophic and eutrophic species. Around 10,645 KUSBP, a rise in Hydorus vericus abundance suggests increasing trophic levels. Fluctuation in thermophilic species and reduced planktonic taxa reflect climate variability and water level changes. Near the end of this period, dominance of macrophyte-associated species like Alona affinis and Alonella axisa suggest a shallow vegetated basin with slightly acidic water and increased organic matter. In conclusion, here is a quick summary. During the Aleurite period, we observe a dominance of planktonic species, suggesting a deep and oligotrophic lake. Later, a shift toward littoral taxa reflects a gradual water level decline and the development of shoreline habitats. In the Younger Dryas, Cladoceran abundance initially dropped due to harsher climate conditions. However, around 12,600 KUSBP, an increase in planktonic taxa indicates a short-term water level rise. This was followed around 12,000 KUSBP by a decline in lake level, which led to the expansion of littoral communities and macrophyte vegetation, evidence of transition toward shallower and more vegetated conditions. In the early Holocene, we observe increased species diversity and the appearance of thermophilic taxa, pointing to warmer and wetter conditions. Littoral zones expanded further, and the lake became mesotrophic, with signs of nearby peatland development. The presence of acid-tolerant species also indicate slight acidification. While water level fluctuated throughout this period, the overall trend suggests a gradual stabilization of the ecosystem. Thank you for your attention.